This video covers when momentum of a system is and is not conserved. So let's say we drop a ball. The initial velocity is going to be equal to 0. So therefore, the initial momentum of the ball is going to be equal to 0. When the ball almost hits the ground, it is traveling at some unknown velocity that is not equal to 0. So therefore, the final momentum of the ball is going to equal some number that is not equal to 0. So notice here that the initial momentum does not equal the final momentum, and momentum of the system is not conserved. Let's do another example. Let's say that we have a box that is sliding and has kinetic friction force acting upon it. Its initial velocity is going to equal some value that is not 0. So the initial momentum is going to equal a value that's not 0. And the box will finally slow to a stop, so we can see that its final velocity is going to be 0. Therefore, its final momentum is also going to be equal to 0. So once again, we see that the initial momentum does not equal the final momentum, and the momentum of the system is not conserved. So momentum is conserved when no external forces act on the system. In these examples before, we said that the system was just simply a box falling and the ball that was falling and a box that was moving. Those were the only two objects that we looked at. The ball had a weight force, which was an external force because it exists because of Earth. And the box had an external friction force, which is an external force because it exists because of the table. So in order for momentum to be conserved, we must expand these systems to include the objects that cause the external forces. So therefore, we must include the Earth with the ball, and this has a weight reaction force. And the box must include the table, which has the kinetic friction reaction force. So now our systems are larger and have no external forces acting on them. We can see that all the internal forces, which are these arrows in the diagram, now cancel and momentum is conserved. Alrighty, so to apply conservation of momentum to the ball question, we would have to pay attention to the mass and the velocity of the ball before and after the collisions. And the Earth. So the mass and velocity of the ball and the Earth before and after the collisions. And to apply conservation momentum to the box system, we would have to pay attention to the mass and velocity of the box and also the internal molecules within the table.